Good afternoon. Welcome to the live session 12. So we will wait for a few minutes for some people to join and then we will start the session. Okay, we will start the session. So I welcome everyone to the live session 12. for the NPTEL course Basic Environmental Engineering and Pollution Abatement with myself Mahalakshmi S, Research Scholar from National Institute of Technology, Tiruchirappalli. This is the general information. This live session for the course Basic Environmental Engineering, Pollution and Abatement is happening every Saturday from 3 p.m. to 5 p.m. And the JMeet link for the live session is MDI VDCP MCG. All these live sessions are recorded and uploaded on the YouTube channel named Mahalakshmi S. We can find it through at Mahalakshmi Shekhar NITT. So now in today's live session, first we will see the assignment 11 solutions. Followed by that, we will see the overview of week 12 lecture and then some sample questions for the week 12 lecture. So first we will discuss the assignment 11 solutions. The first question is thermochemical process which converts different types of biomass and organic waste into solid, liquid, gaseous fuels. Fermentation, gasification, pyrolysis, incineration. So, what is a thermochemical process here means? So, it is a process in which the biomass is converted by the action of heat and chemical reaction. That is the explanation for the thermochemical process. We have seen different types of thermochemical process like pyrolysis and gasification. Here, the right answer is pyrolysis. It gives a solid product like charcoal, liquid product like bio oil, and gaseous fuels also like carbon dioxide. Like that, gaseous fuel can also be obtained from the pyrolysis. However, the gasification can also give all three products, but it mainly focus on the product called syngas. We have discussed this earlier itself, so this is just overview of it. The second question is identify the type of incinerator. We have different kind of incinerator. So incinerator is a combustion chamber where we will be heating the biomasses at a high temperature level so that it releases all the components into gaseous forms mainly, and we will get the ash as the byproduct in this process. So what is this type of incinerator? Is it a fixed bed combustion, rotary kiln, fluidized bed combustion, bubbling fluidized bed? What is this one? This is a rotary kiln. So how this works means we feed the material here through the hopper and it goes into the tray. So this tray is rotating in the horizontal axis and we are supplying the heat energy in this direction, and all the waste materials are coming in this direction. So once these are burned in this rotating tube, and these exhaust gases will get released from this vent, and whatever the products burnt are coming down here as the final products. It contains some unburnt product and some amount of ash also in it. Okay, so this is the rotary kiln type of incinerator. The next question is which is a process that converts the carbonaceous feedstock into combustible gases in the presence of partial oxygen. So this is the major difference between the pyrolysis and gasification, right? So is it a gasification, pyrolysis, combustion? None of the above. In the combustion process, O2 is supplied in excess amount, like it is very adequate for the complete combustion of the biomass, right? And in the pyrolysis process, O2 is not at all present there. So in the absence of oxygen only, this process is happening. And in the gasification process, you supply the oxygen in a very minimal quantity so that both oxidation and reduction reaction occurs in the gasification process. So the right answer is gasification. Gasification is a process that converts the carbonaceous feedstock into combustible gases in the presence of partial oxygen. Next question is, syngas production can be determined by knowing the air flow rate, feeding rate, composition of syngas, all of the above. So first of all, what is the syngas? So this is the gaseous product, right? This is the gaseous product obtained from the gasification process. So this gaseous product from gasification process is of two types mainly. One is a syngas and another one is called producer gas. When you will say these gaseous product as syngas means when you use the pure oxygen as the oxidizing agent for the biomass. Okay, so if you are using other than oxygen, if you are using any carbon dioxide or you are using the steam, okay, like this, if you are using different oxidizing agent for the gasification process, then those gases are called as the producer gas. So now here the syngas production can be a hydrogen or it can be a carbon dioxide. Okay, depending upon the type of feedstock and the equivalence ratio, the product will vary. So these syngas production are determined by all of the above. That is the right answer. So the amount of air flow rate, the feeding rate of the biomass, and the composition of the syngas, all of these are determined in the syngas production. Okay. Next question is, in pyrolysis process, product selectivity depends on operating conditions such as temperature, heating rate, residence time, all of the above. So the right answer is all of the above. So in a reactor, so in the absence of oxygen, we are filling it with biomass. Under the anoxic condition, this is burnt, right? So when this is burnt, it undergoes a different stages, right? Drying and then the volatilization happens, and finally the char production, oil production, all this happens. We can have a different kind of product like a char from it, and we can also obtain the bio oil from it, and then we can also obtain fuel gas from it, right? So three different products can be obtained from the pyrolysis process. So how this is determined means what is the residence time of the biomass in the reactor and what is the heating rate fixed in the reactor, what temperature is prevailing in the reactor. So all of these are going to determine what type of product will be in a higher quantity. Like if we are focusing on the bio oil production, then the conditions should be adjusted so that we will have the higher yield of bio oil when compared to the gaseous product and the solid product. If our focus is on the solid product, then we have to adjust these parameters so that this char yield will be increasing, gas and bio oil yield will be decreasing. This can be controlled with the help of all the three parameters. The next question is, which of the following is the biological conversion route for the production of energy from waste? So biological means it involves the use of microorganism. Is it a fermentation, pyrolysis, gasification, or none of the above? So in the gasification and pyrolysis is a thermochemical conversion process. So coming to the biological conversion process, only left option is fermentation. So what is happening in the fermentation? So here in the fermentation, the biomass are taken for the growth of the microorganism as the substrate. And then with the help of the microorganism, we are obtaining the gaseous product, okay, mainly. Next, identify the operation P and Q. So this is a operation unit for the gasification. So first the coal is fed into the gasifier after the pre-treatment, and we have different oxidizing agent like oxygen, water, and steam. Okay, with the help of this, the coal is now ignited in the gasification chamber, and then we are collecting the raw syngas here. It is after going through the different cleanup stage, the liquid fuels and chemicals are collected, and then separately we are taking the syngas alone out, and H2 is separately collected that can be fed to the fuel cell, okay, for electricity production, or directly this H2 can be provided for the hydrogen fueled vehicles. And then some of the gases, when it comes to the P unit, it is producing the electric power, and then it is coming to the waste heat boiler. So in this boiler, it is producing the flue gas, and after this waste heat boiler, it is coming to the another unit. So in this unit, what is happening means here also the electrical power production is happening. Okay. And finally, the bottom product of the reactor includes the ash and the slags and metal compounds from the biomass. So now what is the unit P and unit Q in this whole operation? They are asking, is it a gas turbine, steam turbine, or steam turbine, gas turbine, pump and generator, pump and compressor? The right answer is gas turbine and steam turbine. First, this gas is coming to this gas turbine, and then once the steam is taken here, so this is going to the steam turbine. Okay, with the help of this only, it is coming here. Now, correct sequence of steps involved in gasification process. It involves a four step. The right order is drying. So in the drying, it removes all the moisture content. So now our biomass will become a dry biomass. And then comes the devolatilization. So in the devolatilization, what happens? Removal of the volatile matters happens. So volatile matters are removed. And then comes the oxidation. So the fixed carbon is almost formed here. So the biomass will form the biochar. However, in the presence of oxygen, what is happening? The gases will penetrate in and out of this biomass again after the reduction process also, so that only the biochar pore size increases. So the biochar pore size amount of pores will be very high. Okay, and then the surface area also gets increases. So this kind of biochar or having the higher quality when compared to the um, pyrolysis biochar. That is the major reason because of the oxidation process. And then comes the ash cooling. So in this one, we have the fixed carbon and the left out ash. So this is the sequence of steps involved in the gasification process. Drying followed by devolatilization, oxidation and ash cooling. Generally, for a single cycle steam power plant, the conversion efficiency of thermal power plant is between. What is the conversion efficiency? They are asking. This is a common question. Right answer is 30% and 40%. This is the conversion efficiency of the thermal power plant. The temperature range of carbonization. So at what temperature carbonization happens? We know the biomass is having a lot of carbon content in it, and then it also has the H hydrogen content, some amount of nitrogenous form, and some few forms of sulfur, a few percentage of sulfur will also be there. But mostly it is a hydrocarbon, lignocellulosic biomass, right? So it is comprised of C and H. So in this biomass, these carbon will get carbonized, and it is going to form different kind of product like this. So now it is going to result in different aromatic compounds, and some will also be escaping in the form of carbon dioxide, carbon monoxide. So the carbonization will start around the temperature 350 to 500 degrees Celsius. So, do you have any doubt in the assignment 11 solution? Okay. So now we will move on to the week 12 overview. So this week 12 is about the air pollution management and some special category waste management. Now coming to the lecture 56, air pollution management. So main aim of the air pollution management is to reduce the airborne gaseous and particulate and biological pollutants. We know that mainly the airborne gaseous pollutants includes the main focuses on nitrogen dioxide and then carbon dioxide, right? And then particulate matter, we know two different forms of particulate matter are there. One is PM 2.5 and another one is PM 10. So this in 2.5 and 10, these numbers indicate the size of the particulate matter. and then to some extent about the biological pollutant also. So totally how these air pollutants should be reduced. That is the main aim of the air pollution management. So, in this one, air pollution abatement plan. So, how to avoid this air pollution? Different plans are made. For that, the emission inventory preparation includes 5 different volumes. So, it is split into 5 volumes. In the volume one, it talks about the emission inventory fundamentals. So, it is a guideline. So, to which we should adhere to. Like all the maximum ranges of each pollutant are mentioned here. And then point sources, area sources, mobile sources. So we know the pollution is from the different sources. So point sources where the origin of pollution is described, we can easily identify, we can correct it from that point itself. And area sources are a group of area where like the industrial areas which are all emitting the air pollutant. And mobile sources, these are the moving sources where we can take the example of the vehicles where it is releasing the lot of air pollutants. And bibliography is having this volume having the reference of certain cases. So how to resolve this? So some specific standards and methods will also be described here in this bibliographies. Next is a controlling measure of air pollutant in industrial establishment. How to control in the industrial establishment. So here, two types of pollutants are discussed while taking the industries. One is the gaseous pollutant. So this gaseous pollutant, as I said, like nitrogen dioxide, nitrous oxide, carbon monoxide, carbon dioxide, these all can be absorbed. So absorption means taking up of these pollutant, like capturing of the pollutant by the help of liquid chemicals, or we can use solids to capture these pollutant. And combustion here, why combustion is important means most of the pollutants are coming from the incomplete combustion of the biomass. So what happens there, the incomplete combustion will result in the release of a lot of carbon monoxide and then to some amount of nitrous oxide. Like that, the incomplete combustion will release the undesired gaseous pollutant. Next, coming to the control of particulate pollutant. So we know that particulate matter are also going to cause many hazardous effect over the health of the human beings. So capturing them in the place of emission itself is very important. For mainly these are emitted from the thermal power plants. So where we will commonly use the ESP, which is the electrostatic precipitator, which ionize the dust particle and capture it. And some other options we have already discussed in details include the gravitational settling chamber. By the means of gravity, the particulate matter are settling down there. And cyclone separator, this is a separator in which, because of impedance of the dust particle against that cyclone, is separating the particulate matter from the air. And fabric filter, it is a filter bag having n number of bag in it, so that it filters or trap the particulate matter in it itself. And electrostatic precipitator we discussed. Wet collectors and scrubbers, so here also we use some liquids for the scrubbing of the particulate matter from the dust air, which are all released from the industrial point of view. Okay. Now we have different air quality standard. So this air quality standard is established and there is a limit on the source discharge and the ambient air quality. And this air quality management is very important. We have a cycle. So in this one, the first step is establish the goal. So what kind of goal we need to establish is to maintain a pollution-free environment without affecting the human beings, without having any effect over the environment. How the air pollution should be controlled. So we first the government will establish some goals to maintain the quality of air. And then the second step is air quality managers will determine the emission reduction. So how to reduce the emission. So to what level we should reduce the emission. So those are all determined by the air quality managers. And the third step is develop control strategies to achieve the established goal. So in order to achieve the goal, The air quality managers will develop the control strategies here in the third step. And then once the control strategies are developed, implement the programs. So programs are implemented. Implementation will not bring a solution to the air quality management. Uh, we should be undertaking the evaluation in the intermittent period of time, so that how much percentage of the established goal is achieved in the purification of deteriorated air. Like this, the intermediate evaluation is also important. This is also done by the air quality managers. Okay. Now we have the National Air Quality Monitoring Program. Initially, this is called as National Ambient Air Quality Monitoring Program. Later, it is renamed as National Air Quality Monitoring Program, which is shortly called as NAMP. So here, the sampling is done for entire 1 day, that is 24 hours. Every 4 hours, the sampling will be done for the gaseous pollutant, and this 24-hour sampling is done twice a week, 2 times in a week. This is done. And we have different zones in India, particularly for these sampling, and there the air quality is assessed continuously. And then we can have an air quality survey so that we can easily collect the information. One of the ways is to site inspect. So we have to go to the site directly, inspect it and observe, we note it down, and then interview, ask the people and interview about the quality of air. Next is the environmental evaluation. Using some monitoring tools, we can evaluate the environmental condition. Next is the WHO air quality database. So this database is updated 2 to 3 years once, and this database compiles the data of the particulate matter and nitrogen dioxide mainly. So all the database, global data are present in this WHO air quality database. Now coming to the lecture 57. So this is also a continuation of the air quality management. We have seen that the government is establishing some goal, and the air quality managers are designing some strategies and how to overcome the air pollution. To make the public understand what is the level of air quality, the air quality index is developed. So this AQI is a tool for effective communication of the air quality status in a particular area. So this air quality status is determined from various parameters like PM10, PM2.5, NO2, SO2, carbon monoxide, ozone, NH3, and lead. So we measure these concentration in the air, and the air quality status is determined. So how we are arriving at this value AQI means, this AQI is formulated with the help of some sub indices. Like before calculating the one index, we calculate many sub indexes. Like for each and every pollutant, we calculate the air quality index through the linear segmented principle. So this is a mathematical calculation. And then aggregation. So after measuring the amount of PM10, 2.5, NO2, SO2, carbon monoxide, ozone, like this, the individual gaseous pollutant are measured once, and how these are aggregated, how these data are aggregated and taking the conclusion means there are different methods like minimum maximum operator, choosing the minimum value or maximum value, or weighted additive, adding all the individual components index, or root mean square of all the components, or root sum power. So different methods are there for coming to the conclusion of the AQI of the particular zone. So in this one, this is one of the example. This calculation is mainly followed in our country. So this equation states IP is equal to here HI and LO are indicating the high and low level. So IP is equal to first I high in I high minus I low divided by B high minus B low into CP minus B low. This whole term is added with I low. Okay, so what does this I and B means? So this I is the index value. So if you see, the air quality index is divided into six categories. So these are the six categories. The first one is good. Good means it indicates 0 to 50, and satisfactory means 51 to 100, moderately polluted means 101 to 200, poor means 201 to 300, and very poor means 301 to 400. Severe means 401 to 500. This is the air quality index. So this index, each and every category is having a high value and a low value. Okay, so the I high and I low indicates the high and low value of the AQI. Okay, and here the B high and B low is indicating the breakpoint concentration greater or equal to the given concentration. So this breakpoint concentration means for each and every PM 10 PM 2.5 we have the six values for each category. Okay, for the sixth category, we have six different range for the PM10 itself. So, if our PM concentration is PM10 concentration is 50, we will choose the 50 range here in the sixth category, and it will also have some high value and low value. That value belongs to the B high and B low. And CP here is the present concentration of the pollutant in the atmosphere. Okay, and we will be using this formula to calculate the pollution index. Okay, individual pollution index, like for each and every gaseous pollutant. And finally, how the aggregation is done here is taking the maximum of IP. Say for example, in our air we are measuring the PM10 2.5 and nitrogen dioxide, and the highest value among the three is nitrogen dioxide, means we will take this value as the AQI value of the particular area. This is the procedure we are following. Okay, please know this formula. When we are solving the problem, you will understand it better. Okay. So now for the six categories, what are the associated health impact is mentioned in this table. So if it is good, it is going to have only a very minimal impact. If it is satisfactory, it may cause some minor breathing discomfort to only the sensitive people. And moderately polluted means it may cause the breathing discomfort to people with some diseases like asthma, and it can also discomfort to the people with heart disease, and it will disturb the children and old adult people. Okay, and in the case of poor condition, poor air quality, it is going to discomfort the people on a prolonged exposure. So when it is when the people are exposed to it continuously, it is going to cause the discomfort to the people. And very poor means it is going to cause the respiratory illness to the people on prolonged exposure. So everything is on the basis of prolonged exposure. Okay, and in the severe case of air pollution, it may cause respiratory effects even on healthy people. To healthy people also, it will cause some impairment, health impairment in the case of severe air pollution. Okay, it will mainly result in the lung and heart diseases. And these health impact may be experienced even during the light physical activity. Like people are telling that the motor signals can also get affected, so that the driving skills can also get affected because of the continuous exposure to the poor air quality. Okay, and now we have different AQI example. In India, we follow this type of AQI. We have different air quality index. If you see the green index, it includes mainly the sulfur dioxide and COH, and the Ontario air pollution index will measure the COH and SO2, and the MURC, which is most undesirable respirable contaminants index, will measure COH only, and Oak Ridge Air Quality Index will measure SO2, NO2, PM, carbon monoxide, and some of the photochemical oxidants. And Indian Air Quality Index, it uses the linear segmented principle, so that we use this equation, and then we use the maximum operator to arrive at the aggregated value. That's why our AQI is the maximum of IP, where IP is obtained with the help of I high and low and B high and low using this equation. Okay. Now coming to the lecture 58. So this 58 and 59 lecture deals about the special waste treatment procedures. So what is this special waste means? These are also some way, in some ways hazardous. It can also be non-hazardous. But this is a solid waste that requires a special handling and management to protect the public health and also the environmental health. Mainly, these special waste are categorized into two types. One is the biomedical waste, and the other one is the e-waste. So, these biomedical waste are generated from the biological and medical sources and activities, mainly from the hospitals and clinics. And these wastes are further categorized into 10 types. Okay, we'll see these categories, you will get an idea. So the category one is the waste content, the human anatomical waste, where the human tissues, organs, and human body parts are the waste materials here. So how these waste are treated and disposed means it is mainly incinerated. So incineration is the only way to kill the microorganism so that it avoids any further spreading of diseases into the environment. So, maximum of these biological waste or biomedical waste are incinerated, and then they are deep buried. Okay. And then the category two is the animal waste. So here it includes the animal tissues, animal organs, and animal body parts, carcasses, bleeding parts, the blood, and the experimental animals used in the clinical research. We use mice, rat, and then we use rabbit, monkeys for testing of the drugs, right? So these are all the experimental animals. So once these animals are died, we cannot just like that bury them. We have to incinerate them to kill the pathogen in the body. Mainly these wastes are generated by the veterinary hospital colleges and discharged from the hospital and animal houses where the experiments are carried out. So these also should be incinerated and then deep buried. Next is the category 3 waste. It includes the microbiology and biotechnology waste. So these wastes are from the laboratory cultures. So we use the cell culture studies to check the effect of some uh, chemicals or drugs, so that it is from the laboratory cultures, it can be from the industrial laboratories. So these wastes are produced from the biologicals. So how these wastes should be disposed of means it is less to some extent when comparing to category 1 and 2, it is less hazardous. So it is this kind of pathogens can be easily killed with the help of autoclave or microwaving. If it is very persistent microorganism, then it should be incinerated. Okay. Then coming to the category 4, waste shock. So this waste shock management itself a very complex thing. If you see, these includes the needles, syringe, scalpel, and the plates, glasses. These materials are very sharp in nature, and with use or without use, it is going to affect the community, because the puncture of the used syringe or needle to a healthy individual itself is enough to transmit the diseases. So handling of these waste shark is absolutely very critical. So how these are treated and disposed means first it is disinfected with some chemicals, and then it is autoclave or microwave, sometimes multilation shredding. So these are sharp points are shredded enough to ensure that no further contact with the human easily will happen. Then is the category 5. This includes the discarded medicine and cytotoxic drugs. So like contaminated, outdated, expired medicines, all these waste comes under this category 5. So these are also incinerated, or these drugs can be disposed in the landfills. So now the category 6 waste includes the solid waste. So what is this kind of solid waste means? These items contaminated with the blood, body fluids, including the cotton. Like when we are dressing the wounds, we have the blood stains in the cotton also, and some soiled plaster casts after the fracture and all. We will be having some plaster cast. Some other materials which is getting contaminated with the blood are called as the solid waste in this category 6. So these should be incinerated, and then autoclaving and microwaving is also preferred. Next is the solid waste in the category 7. These waste are mainly generated from the disposable items other than the waste shop. So, apart from the sharp items, it is like the tubing, catheter, intravenous set. So, all these are the solid waste coming under the category 7, which is not sharp in nature. So, this can be disinfected with the chemicals and then autoclaved, microwave, and then shredding is also important. Next is the category 8. This includes the liquid waste. So where this liquid waste is coming means it is from the laboratory during the washing, cleaning or housekeeping or disinfecting activities. So these are disinfected with the help of the chemicals, and then these liquid waste can be discharged into the drains. Next is the category 9 waste, which is the incineration ash. Whatever the ash produced from this incineration process is coming here as the incineration ash, which itself a waste for the category 9. So these are the ash from incineration of any biomedical waste. So these should be disposed in the municipal landfill. Landfilling is the preferred method. Next is the category 10, chemical waste. So the chemicals used in the production of biological and the chemicals used in the disinfection such as insecticides, etc. So these are the different chemicals used in the industries. So now these are also chemically treated and can be discharged in the drains itself. Okay. So the treatment is very important before disposal of any category waste. But right way of treatment and disposal will determine and reduce the effect over the human health and environment. So now the different steps involved in handling of the biomedical waste includes the collection. First is the collection of the waste and then the segregation. If you see, segregation is the most crucial step because we have n number of waste in this biomedical waste. So these all can be selected, but segregation according to the category is very important because that only going to determine the final uh, disposal process. Okay. Now after the segregation, like we easily can separate it, but it is always difficult. We are having a huge quantity of the waste material. So how in real time, if we are segregating in the hospital or clinics itself, means we have different kind of dustbin. If you see, we have yellow dustbin specifically for the human and animal waste products, and then we have the red one to collect the plastic waste, and the blue color. Like this, we have different colored dustbin which indicates the disposal of the medical waste product. But however, in a huge quantity, once it is received, only people are separating. So the segregation is very crucial one in the treatment steps. Now comes the storage and then the transport. Here the treatment and disposal is of a further type. As I said, the treatment and disposal will depend upon the type of the waste material only. We have different treatment and disposal methods. One includes this destruction. So destruction is like a complete killing of the existing microorganism or any pathogen kind in the waste. So that we prefer the high temperature incineration. We can also use the plasma arc or other any high temperature heating substance to destruct the waste material. Next is the disinfection. So disinfection is if it is a lower category of hazardous waste, then we can go for the chemical disinfection, or else we can go for autoclaving. So autoclaving here means sterilization. So the sterilization is normally 121.1 degrees Celsius for 20 to 30 minutes. That is the standard time. This means that complete sterilization, that is the removal of microorganism, will happen. So D value means this is a decimal decay constant. So how much time it is taking to reduce the microorganism content from 100 to 10 percentage. That is the D value, and the Z value here indicates the time required. So what is the amount of time required to achieve or increase the D value by 10 times? So what is the time required? And then time difference, or sorry, temperature. This is the temperature coefficient. So what is the temperature required? Okay. Usually this is taken as 10 degrees Celsius. and F naught is the exposure equivalent exposure time. So here, instead of achieving 121 degrees Celsius, we can also go for 150 degrees Celsius, or we can go for 105 degrees Celsius. But the holding time, how much time that waste should be autoclaved, that holding time will differ from 20 minutes. That equivalent amount of time is calculated with the help of the F naught value. And then we have the microwaving, which uses the microwave for sterilization. Then is the hydroclaving. Hydroclaving is similar to autoclaving but uses the less amount of water for sterilization. Next is the disposal method. For the coming to the disposal method, we are going to ultimately send it to the land. So it is a land filling. It may also include the deep burial of the waste. So when we are talking about the deep landfilling or deep burial, minimum the depth should be a 2-meter height. Okay. Now coming to the lecture 59. So this lecture is talking about the handling of e-waste, which is nothing but the electronic waste. So in this modern world, electronic waste is inevitable. We are using different gadgets. So ultimately, the e-waste production is reaching millions and millions of tons. So what is the major source of the e-waste material means? Computer devices, which includes the mouse, monitor, and keyboard, and the electronic devices like TV, DVD, CD players, and then the audiovisual components, stereo equipments, and household equipments also come under the source of e-waste, like the vacuum cleaner, washing machine, and then the air conditioner. Next, the communication devices. These are now one integrated part of the human life. Like mobile phones are there in every household to every individual person. So this mobile phone landline, it is very rare, and then the fax machine. So mainly this mobile phone is also produced in higher quantities nowadays. So these waste are the e-waste. So why this management of e-waste is very important means, so what is this, for that you should know what is the composition of e-waste. So if you look into the composition, it is 30% only organic, like it can be a polymer, glass fiber, flame retardant. So only 30% is organic and 30% is ceramic. So ceramic means mica, silica, and alumina. And another 40% is inorganic, which includes the ferrous and non-ferrous metal. Along with it, it will have some poisonous compounds like mercury, lead, like that. So the treatment of e-waste is very important here. And if you see the adverse effect over the human health because of this e-waste, we have several health impact. If you see, dioxin is one of the compound. It will damage the entire body system by damaging the immune nervous system, endocrine system, and the reproductive system. It is having this much damage to the different part of body. And then arsenic means, so here arsenic, we know it is a carcinogen. It can cause the cancer. It also cause diabetes and cardiovascular disease. Mercury, we know it is a poisonous compound. So mercury poisons the eyes and lungs. It affects the skin, kidneys. It can also cause damage to nervous system, digestive system, and immune system. Lead is also a poisonous compound. So lead causes the cognitive and verbal impairment, especially in the children. Okay. How these materials like lead, mercury, copper, cadmium, arsenic are getting in contact with the human beings. So once these are disposed of, it is again going for landfilling. So all these materials are buried deep inside the land, which is in contact with the groundwater table. So the leaching of these chemical compound into the water will bring it to contact with the human beings. This is how all these hazardous substances are getting in contact with the human beings. Now coming to copper, it will negatively affect the lungs and kidneys, and cadmium, it weakens the bone by interfering with the body's ability to metabolize the calcium. So it is going to affect the calcium metabolization, so it is going to weaken the bone. So this much health impact is caused because of the improper e-waste management. Okay. So now how these e-waste can be effectively managed? What is the best way? If you see waste collection, firstly the waste should be collected, stored, treated properly, and then only disposed. Then institutional mechanism and coordination. So from each and every sector, this coordination is essential to manage it. And then legal framework and enforcement. Government should have a legal framework and it should enforce it among the public. And then capacity building and awareness. Awareness is very important to the people. Import and export of the product, we should try to reduce it. And then waste minimization. Ultimately, if we reduce it, waste will also minimize. And then monitoring, evaluation, and reporting. We have to be monitoring the production rate of the waste, e-waste, and then we have to evaluate and report on time. And resource mobilization. We should try to utilize this e-waste for our further requirement itself. That is what coming to the another topic called recycling of e-waste. So these e-waste is not completely unessential. We can also obtain some useful product. We can recycle this e-waste. Like we can reuse the plastic components, we can reuse the metal component, we can reuse the mercury for any other purpose. Like instead of taking the new form of mercury, we can recycle from e-waste and use the mercury for other application. And then we can recycle the e-waste for batteries and circuit boards and all. Instead of just disposing it off, we can recycle them. So this recycling of e-waste into these different types of product involves different methods. So some of the methods are listed here. One is the hydrometallurgical, pyrometallurgical, biometallurgical, and electrometallurgical method. If you see, this is the flow sheet of effective recycling of the e-waste. The first step is the e-waste collection, and then it is prepared, like it is separated based on the size, based on the type, and then it is disassembled, and then the size is reduced here. Then it comes for the physical separation or enrichment, like by using the magnetic or electrostatic or eddy current based separation. These waste are all separated. Okay. And then we know it contains the organic part, ceramic part, and inorganic part. So organic part can be separated. So the organic part once separated can be used for the biometallurgical treatment. So in the case of biometallurgical treatment, it is mainly biosorption, like taking up of these heavy metals with the help of the living organism. It can be a microorganism or it can be a plant. So any kind of living organism can be used for taking up of the uh, compounds present in the e-waste and making them less hazardous. Or it can be bioleaching. One form is biosorption and another form is bioleaching. So bioleaching means with the help of those living organisms, that is the microorganism, we can leach the component from it, then we can reuse those components for other application. Next, it can be hydrometallurgical. Hydrometallurgical here, it means leaching, but with the help of acids. With the help of acids, we will leach these e-waste and we can recover the compounds from it. Pyrometallurgical. So pyro means here we are using heat energy. So heating of it at high temperature. So it includes melting, smelting processes to recover the metals from it. And then it can be electrometallurgical method, electrolytic recovery refining. With the help of electrolytic plate, we can use the heavy metal in it for coating of any compound. Like that, based on the electrometallurgical method also, we can recycle the e-waste material. So these are the different methods of recycling the e-waste. So with this overview, shall we move on to the assignment 12? Any doubts so far?
Yes, ma'am, we can move.
Okay. So now coming to the sample question for assignment 12. The first question is, which of the following process is not inbuilt in the atmosphere to clean itself? Dispersion, flocculation, absorption, and qualification. So, the right answer is qualification. So, here, dispersion, we know that initially the air will be heavily contaminated like this. So, these gaseous pollutant, when it comes in contact with a larger area, its concentration will get decreased. Like we will be adding some fresh air to the atmosphere like this. So, the pollutant will be dispersed into the atmosphere. So flocculation is another chemical process, and by absorption is also another chemical process to capture or remove it. So these are all not these are all some of the atmosphere cleaning process, but qualification is totally different. So this is a process where the organic matter content in the earth is in high temperature and pressure. So temperature and pressure, under high temperature and pressure, organic matter or organic content will be converted to coal. Okay, this is not happening in atmosphere, and it is not related to cleaning of the atmosphere. Second question is, which of the technique is used in industry to control the particulate pollutant? So particulate pollutant here means particulate matter. Is it a fabric filter, combustion, absorption by solid? None of the above. So particulate pollutant means we use the fabric filter. For the gaseous pollutant only, we go for the combustion and adsorption by solid or adsorption by liquid. Okay, these are all for the gaseous compound, and this is for the particulate matter. Next question is calculation of green index. We have seen the different air quality index. Green index is one of them. So the calculation of green index included the sub-index of two variables, FeO2 and CO3, SO2 and COH, NO2 and CO2, CO2 and CO. The right answer is SO2, sulfur dioxide, and COH. Okay. Based upon these two sub-indices, the green index is calculated. Next question is, which of the following is not a source of hazardous waste? Like we know that hazardous waste is having extremely harmful effect. So which of these is not having any hazardous effect, they are asking. Radio imaging ward, dressing room, operation theater, and restroom. Radio imaging, radioactive components will be released, and in the dressing rooms we have the blood related blood contacted waste, right? Like cotton, like that. And then in the operation theater, we have again many blood tissues, like that. We have many hazardous compounds there also. But in the restroom, it is not like that. It is not a source of hazardous waste. Okay. So the right answer is restroom. Next, the correct sequence of steps involved in the management of medical waste. Just now we have seen the steps involved in the biomedical waste management. So the right order is, first is collection, next is segregation of the waste based on the category. This is very important. And then third is storage. Next is the transport of waste. Then fifth is treatment and disposal. Which statement is not true about the segregation of biomedical waste? Segregation refers to the basic separation of different categories of waste, which is correct. Segregation is the easiest step in the biomedical waste management. This is wrong. It is not the easiest step. It is the most difficult step, because we know there are 10 categories of waste. We have to segregate it uh, by these 10 different categories. Segregation reduces the need for special handling and treatment. This is right. So once you are segregating it, then you can send that batch directly to that particular treatment method. Effective segregation can ensure the effective management of biomedical waste. That is right. So the wrong answer is, segregation is the easiest step in biomedical waste management, because it is not easy. It is a tedious process, and it is also a crucial step. Okay, it's not easiest step. FO F naught value provides the lethal equivalence between expected and practical condition for autoclaving and can be expressed as which equation they are asking, where delta T is the time interval between two temperature reading. T is the temperature at time T of the product under sterilization. Z is the temperature coefficient, assuming that Z as 10 degrees Celsius. So it is always taken as 10 degrees Celsius. So as I said, we have an autoclave. Okay. So in this autoclave, there is a temperature gauge and pressure gauge. So which should be always maintained here. Normally, this sterilization has a standard of 121.1 degrees Celsius with the holding time, like this at this temperature, the waste is holded for the time of 20 to 30 minutes. Okay, if you are changing this temperature to any other temperature, unknown temperature means, then this time will also gets changed. Okay. This difference can be obtained with the help of the F naught. Okay, this is the equivalent time exposure. This will give you the equivalent amount of time. So now the right relation is F naught is equal to delta T summation of 10 power capital T minus 121.1 divided by Z. This is the right relation. Okay. Identify the steps C and D involved in the recycling of e-waste. So what are the steps C and D? The sequences collecting and transporting of e-waste, shredding and sorting of e-waste. Next comes the C. Next magnetic separation. Then D. Purification of waste stream. Preparation of the recycled material for sale. So the right answer is after shredding and sorting, we will remove the dust. So dust extraction happen. Then magnetic separation, like using the eddy current or magnetic force, we are going to separate the particles. Okay. So next D is the water separation. Okay, we will separate the water, like we will leach it and we will separate. Then comes the purification of the waste stream. This waste stream is purified and our product is also prepared for the recycled material for sale. Okay. Next question is methods used for metal recoveries from e-waste. We know that e-waste is containing many metals like uh, cadmium, copper, arsenic, lead. So here how these metals can be recovered: hydrometallurgical process, pyrometallurgical process, biometallurgical process. It is all of the above. You can use acids to leach the metals. You can use the heat to melt and capture the metal. We can also use biosorption or bioleaching method to recover the metal from the e-waste. So the right answer is all of the above. Next, this is a problematic question. The question is ambient air concentration. Ambient concentration of CO2. So ambient CO2 concentration in a city is 500 ppm. It is in volume percentage on a particular day. Express its concentration as mg per liter of air, assuming this standard condition. Okay, assuming STP. So now they have mentioned the concentration as 500 ppm. They are asking us to find the concentration in terms of mg per liter of air. Okay. So the right answer is 0.981 gram per liter. Now we will see the solution. So 500 ppm means 500 parts per million amount of air. That is right. So it is nothing but 500 into 10 power minus 6 liter of CO2 in 1 liter of air. Okay. So this is how we are rewriting this 500 ppm. Now we know the volume percentage in the air. They are asking you the concentration. To find the concentration, okay, that is the first to find the concentration in mg per liter, we have to find the weight in terms of mg. Okay, so for this we are using the standard equation, ideal gas law. PV is equal to nRT. So now we should substitute all the known values here. Like we know it is STP condition, right? So substitute the pressure, it is standard, so 1 atmosphere pressure. And now we know the volume percentage, 500 ppm. So 500 into 10 power minus 6 liter. And N is unknown. R is standard, okay, which is 0.082 liter atmosphere per mole Kelvin. And temperature is also for STP condition, it is 273.15 Kelvin. So substitute all the known values here. Now find the N value. Now we have found that N is equal to 2.23 into 10 power minus 5 moles. With the help of the moles, you can easily find the concentration. How? Moles is equal to weight by molecular weight. You want the weight of the CO2. For that, you just multiply the moles with the molecular weight of CO2. So CO2, O2 is 16 into 2, which is nothing but 32, and carbon, the weight is 12. So 12 into 1 is 12. So the total weight is 44, right? So this is the molecular weight of carbon dioxide. So multiply the moles into the weight, which is 9.812 into 10 power minus 4 gram. Okay. Now the concentration is asked in mg per liter. So again, this gram is converted to mg so that it becomes 10 power minus 3 gram. So this points goes one digit to the left, which is 0.9812 into 10 power minus 3. 10 power minus 3 is nothing but mg. So 0.9812 mg per liter is the concentration of the CO2 in air. So this is how, with the help of the ideal gas law equation, we are converting the volume percentage into the concentration in air. Okay. Any doubt? Any doubt so far in the assignment question? Shall we move on to the tutorial problem? Okay, no doubts, we will move on. So now the first question is similar to the assignment question with different value. Okay, so here the ambient concentration of CO2 in a city is 450 ppm on a particular day. Express its concentration as mg per liter, assuming these standard condition. So now here the basis is 1 liter of air. So 450 ppm is 450 into 10 power minus 6 liters of CO2 in 1 liter of air. With this, you know the volume percentage. Again, use the formula PV is equal to NRT. P is 1 atmosphere, V is 450 into 10 power minus 6 liter, N is unknown, R is standard 0.082 liter atmosphere per mole Kelvin, and temperature is for the standard condition 273.15 Kelvin. So now we will obtain the N value. So N is the mole. So again, N is equal to weight by molecular weight. So you have to multiply with the molecular weight of CO2, which is nothing but 44. So you will obtain the value of 883.96 microgram. To convert it into mg, 0.884 milligram. So assuming 1 liter of air, so the concentration of CO2 in atmosphere becomes 0.884 mg per liter. Okay. So now this is a same kind of question, but with a small modification. So we'll see this one. Carbon monoxide affects the oxygen carrying capacity of lungs. Whenever we are inhaling the carbon monoxide, it is affecting the oxygen carrying capacity of lungs. Exposure to 50 ppm carbon monoxide for 90 minutes at standard temperature and pressure has been found to impair one's ability to discriminate the stopping distance. Thus, motorists in heavily polluted areas may be more prone to accident. So when this carbon monoxide at the concentration of 50 ppm is exposed for straight 90 minutes at standard temperature and pressure condition, it is going to affect the motorist health, so that the motorist cannot stop the vehicle, uh, so that accidents are happening. Are motorists at a greater risk to accident if the CO concentration is 65 microgram per meter cube? Here, the concentration of the carbon monoxide is given, but the data initially given as the exposure limit is like beyond this limit, it is going to cause impact over the human health. That data is given in ppm, which is nothing but volume percentage, right? This volume by volume. But here, the concentration which they ask to check whether it is possessing risk or not is given in microgram per meter cube. So what we have to do means, we are now going to convert the concentration to volume percentage. Okay. Initially in this problem, the volume percentage is given. We have converted it into concentration. It is just vice versa. Okay. Since the concentration here is mentioned in the unit microgram per meter cube, we are assuming that volume of air is 1 meter cube. Okay. And the standard temperature is 298 Kelvin, and we are going to substitute it here. So now the same formula, PV is equal to nRT, but here what is the unknown one? Volume. So V is equal to nRT by P. Okay. Then first we need to find the N value. So we know N is equal to weight by molecular weight. We know the concentration, which is nothing but 65 microgram. Okay, so this is the weight. And what is the molecular weight of CO? For carbon, it is 12. For oxygen, it is 16, right? So it is nothing but 28. Okay, why? But it is wrongly written here. So we have to substitute the molecular weight here, and then we have to divide the weight with molecular weight, so that we'll obtain the moles of the CO in the air. Then what we are doing, substitute the moles obtained here, and we know the standard condition, R value 8.205 into 10 power minus 5 meter cube atmosphere, and temperature 298 Kelvin, pressure 1 atmosphere. Substitute everything, you will obtain the volume percentage, which is nothing but 0.0538 ppm CO. But here the exposure limit, if it is 50 ppm for 90 minutes only, considered as hazardous. It is way lesser than 50 ppm, so the motorists are not at a great risk. So if the concentration is given, we can use the same formula to find the volume. If the volume is given, you can use the same formula to find the unknown concentration. Okay. Now coming to the next question. So it is a combustion based problem. A refractory combustion unit lined with no water wall and no heat recovery is burning refuse derived fuel consisting of 80% organic, 12% water and 8% inorganic or inert at a rate of 19,920 kilogram per day. Uh, Now, determine the temperature of the stacked gases, assuming the following. The question is to find the temperature of the stacked gas. Okay, these are all the data given to find the temperature of the stacked gas. let's see what are all the data given. Heating value of RDF, that is a heating value of fuel is 19,000 kilojoule per kg on dry ash free basis. Okay. Stack gas flow rate is given as 8,200 kg per hour, and 7% of the heat input is lost in the form of radiation. So one type of loss is radiation, and 15% of the RDF remains uncombusted in the ash. So another type of loss is incomplete combustion. It is present in the ash itself, and ash exits the combustion chamber at the temperature of 750 degrees Celsius. Specific heat of ash is 0.3837 kilojoule per kg per degree Celsius, and specific heat of stack gas is 1 kilojoule per kg per degree Celsius, and latent heat of vaporization. So vaporization is also carrying some amount of heat. This is the another form of wastage of our heat energy, which is the latent heat of vaporization is 2575 kilojoule per kg. Now considering the combustion unit, so here the combustion is happening. So what is burnt here means RDF. This is the fuel which is burnt here. Okay. This RDF is fed at the rate of 19,920 kg per day. Okay. Now this is burning here. Initially in this combustion chamber, the RDF is fed. Okay, and then we are experiencing different type of loss. One is from the ash, because the RD some percentage, that is what, 15 percentage, 15 percentage is not burnt properly. Okay, it is not 15% ash. I'm just writing the data here. 15 percentage is unburnt here, and the next is radiation. Okay, so in the radiation, what is happening, 7 percentage of the heat is lost. Next is vapor. So here the latent heat of vaporization. So vaporization is also happening. So through this, the heat energy is lost. This input energy is lost in three forms. Okay, and then only to the stack this is going. So now our aim is to find the stack temperature. But some of the heat losses are happening after the heat loss. After subtracting the total losses from the input energy only, we will find the exact temperature going to the stack. Okay, so let's see how we will calculate each and every section here in detail. So first of all, this RDF is fed at the rate of 19,920 kilogram per day. So in a day, 24 hours are there. So convert this to per hour basis, because all the units are here in given in hour. Okay. So 19,920 divided by 24 is 830 kilogram per hour. Okay. Next is the composition of RDF is 80% organic, 12% water, and 8% inert. This is also another data related to RDF. Now, take the heat of combustion. Okay, so how much heat is generated during the combustion? For that, we have to multiply the mass of the mass flow rate. Okay, what is the mass fed at the particular rate, and then percentage of organic. Only the organic is going to be burnt during the combustion process. So multiply it with organic percentage, and then the heating value of the RDF. Okay. So we know that the rate of feeding of the RDF is 830 kilogram per hour. Okay. Write it here. Amount of organic which is going to get combusted is 80 percentage, which is nothing but 80 by 100, 0.8, and the heating value is given already, which is nothing but 19,000 kilojoule per kg. Okay, so this is 19,000 kilojoule per kg. So kg will get cancelled. You will get the final unit kilojoule per hour, which is nothing but this one. Okay, 1 crore 26 lakh 16,000. So now next, coming to the different kind of loss of heat. First we will see the ash. So to the ash, so here the feed rate is 830, that is remaining constant. But here not only the inorganic content. These inorganic content or inert material will come into the ash. Along with that, it is mentioned that 15% is unburnt. That is also coming to the ash part. So 830 into 0.08 is the inert percentage. Okay, and 830 into zero point 0.8. In the 0.8 percentage of organic, 0.15 percentage is uncombusted. So multiply it again with 0.15. Next is the temperature. What is the temperature of the ash leaving means 750 degrees Celsius. So 750, specific heat of ash is already given, which is nothing but 0.837 kilojoule per kg degree Celsius. So once all the units are cancelled, it is 10 lakh 42,000, sorry, it is 1,04,206.5 kilojoule per hour. Okay, so one loss is now calculated. And to the radiation, how much amount of heat energy is lost? Let's see here. So here, from the combustion, already the data given is from the combustion part, 7% is lost. Now we know the combustion loss, combustion total heat value. So multiply it with 7%, which is nothing but 0.07. We will obtain 8,83,120 kilojoule per hour. This much amount of heat energy is lost in the form of radiation. Next, coming to the form of loss, vaporization. So here in the 830 kg of the biomass fed per hour, it contains 12% of water. So multiply it with 0.12. Okay, and the latent heat of vaporization is 2575 kilojoule per kg. Okay, we will obtain the value of 2,56,470 kilojoule per hour. Now subtract all the form of losses from the heat of combustion. Okay, we'll obtain this value 11 lakh sorry, 1 crore 13 lakh 72,204 kilojoule per hour. So why this is important means from this only we are going to calculate this much amount of heat is going to the stack. Then with the help of this only we are going to calculate the temperature of the stack gas. Okay. So heat to the stack is again equal to, this is the same split up written here and all. Okay. Heat is equal to mass into temperature into specific heat. Now we know the total heat to the stack. Okay, substitute it here. Okay, it is written here. Now mass is 8,200 kg per hour. Okay, this much mass is fed. Okay, we have the stack gas flow rate here, and temperature is unknown. That is what we need to find out in this question. Next is the specific heat of stack gas. So specific heat of stack gas is given as 1 kilojoule per kg per degree Celsius. Okay. Now divide this value with 8,200. You will obtain the value of 1,386. This is the range. Okay. This is 1,386.85 is the final answer. So this is the temperature of the stack gas. It is obtained from the heat to the stack gas equation. Okay. Before calculating any temperature, you have to find the amount of heat transmitted there. Considering all the data given, like a different form of heat loss, we are subtracting the heat loss from the heat of combustion to arrive at the total heat sent to the stack. With that heat amount, we are calculating the unknown temperature to the stack. Okay. Any doubt? Shall we move on?
Ma'am, explain heat loss to ash once again. Heat loss to ash,
Okay.
ash part.
Ash pile. So, what is going to be converted to ash is the inert material, because already the composition of the fuel is mentioned here. 80% organic. So, this organic, once it is burnt, it is going to release as the stack gas to the stack. Okay. Next is the water. This water will vaporize. That loss is calculated in the vaporization. 8% inert is the only compound we know without any data that is going to be converted as the ash. But one more data added in the question itself is 15 percentage of the RDF, like 15 percentage of the fuel is not combusted. It is also present in the ash itself. Okay. So now we know 8 percentage of 830 kg is converted to ash. Along with that, we know 15% of this 80% organic is also uh, remaining unconverted. Okay, that is uncombusted. That's why we are adding the total mass. This is the inert mass. This is the organic fraction mass which is not combusted. Okay, is it clear?
Yes, ma'am. Clear now.
Okay. Okay, now we will move on to the next question. It is based on the air quality index. It is very interesting also. Calculate the air quality index corresponding to a region with 24-hour PM 2.5 concentration of 41 microgram per meter cube. 24-hour PM 10 concentration is 58 microgram per meter cube. 24-hour sulfur dioxide concentration is 9.5 microgram per meter cube. So once this question is given, you should remember this formula. Okay. So first you should calculate the sub-indexes of the PM 2.5, then PM 10 and the SO2. Then you have to take the maximum value of these three as the air quality index. Okay, this is the right procedure. So first you will be having this table. So this is the reference table. So we have different categories as we discussed. Six categories are there: good, satisfactory, moderately polluted, poor, very poor, and severe. Okay. And for our pollutant alone, the data are given. We have different number of pollutant. For our pollutant, the ranges are given for the six categories. Now mark where our given concentration comes in this category. So for the case of 2.5 particulate matter, it is 41 micrograms per meter cube. So 41 comes between the 31 and 60, right? So it is between 51 to 100 AQI range. Next, our PM10 concentration is 58 microgram per meter cube. So it is coming between the range 51 to 100, which is also again satisfactory. Okay. And the SO2 concentration is 9.5 microgram per meter cube. It is between 0 to 40 and it is coming under the category good, which is nothing but 0 to 50. Okay. So for each and every case, first you have to write the I high and I low, which will be very easy for you to solve the question. Okay, I high, I low, and then the break point. Okay, this is the break point. Okay, break point of your particular pollutant, and this is the air quality index range. Okay, so if it is 0 to 50, the high value is 50, low value is 0. If it is 31 to 60, the high value of breakpoint is 60, low value is 31. So if you write it initially as a table, then it will be easy for you to solve. B high and B low. Okay. Now take the PM 2.5 and then the PM 10. Next is your SO2. So we know that 2.5 is in the range 51 and 100. And one more thing is, if your I value is more than 50 means what you have to do, if it is greater than 50, you have to subtract 1 from the I low. So here it is 51 to 100. It is more than 50. So from the lowest value, you have to subtract 1. So that is nothing but 51 minus 1 is 50. It is for easier calculation only. Okay, 51 minus 1 is 50. So your I low is 50. For this also, your I low is 50. Okay, and your I high is 100. For both PM 2.5 and PM 10, I high is 100. Next, your breakpoint value, individual values. These will be getting changed. Don't confuse these two terms. I means it is index and B is the breakpoint. Okay. Now, B high and B low for 2.5, you have to take it here. So, the B low is 31. High is 60. Okay. And for the case of PM10, high is 100 and low is 51. You should not subtract 1 from the breakpoint. You should subtract 1 from only the index value. Okay, that is also to be noted. Next, for the SO2, what is the I range? 0 to 50. This is less than 50 only, so no need to subtract 1 from the I low. So I low here is 0 and I high is 50. Okay. Next, our breakpoint is 0 to 40. So B high is 40 and B low is 0. Now with this everything is found. Okay. Then finally you write the concentration of your individual pollutant. That is the given concentration. It is 41 for PM 2.5 and for PM 10 it is 58 and for SO2 it is 9.5. Okay. Now all the data are easily available to you. It is now very easy to solve. We have the formula IP is equal to I high minus I low divided by B high minus B low into CP minus B low plus I low. Okay. So for PM 2.5, first we will solve this one. So I high minus I low means it is nothing but 100 minus 50. It is written here divided by B high minus B low is 60 minus 31. So 100 minus 50 divided by 60 minus 31 whole multiplication of CP minus B low. CP is 41. So 41 minus 31. We multiply this first. Okay. First you divide this, then you subtract and multiply this value. Then I low you have to add it to the total value, which is nothing but 50. Okay, then you will obtain the IP of 67.24 for PM 2.5. Similarly, for PM 10, subtract these 100 minus 50 divided by 100 minus 51. Okay, into 58 minus 51 plus 50. Okay, the value is 57.14. For the sulfur dioxide, again do the same thing. I high minus I low is 50 minus 0 divided by B high minus B low is 40 minus 0. That is what written here. Next, into CP minus B low, which is 9.5 minus 0. Write it here. Plus I low is 0 again. Okay. So the value is 11.87. We know that our aggregate value, that the final value of AQI is based on the maximum theory. So it is the maximum of IP obtained. We have three IPs: 67.24, 57.14 and 11.87. The maximum value is 67.24. So our AQI value is considered as 67. Okay. Now see, 67 is in which range? It is between 51 to 100. Okay. So this is this type of air is classified as satisfactory. Okay. So the AQI is satisfactory. Any doubt? Any doubt in the AQI calculation? If no, we will move on. It's very simple, but one thing is you should not confuse with the data, so that if you make this table earlier, you will not have the chance of losing the marks. Okay. Now, coming to the next question. Calculate the following for the sterilization of biomedical waste, needles, scalpel, blades, etc. using an autoclave. Consider sterilization hold time of 20 minutes at constant 125 degrees Celsius. What will be the equivalent exposure time? That is the F naught value. What does the result signify? And B part is, if the equivalent exposure time is 30 minutes at constant temperature of 110 degrees Celsius, how long will it take to complete the sterilization? What does this result signify? So both the cases are same. We use the same formula. Like this is a standard formula. Note it down. So F naught is equal to delta T summation of 10 power T minus 121.1 divided by Z. But in the first case, the holding time delta T is given. It is 20 minutes. Okay. And the temperature capital T is given as 125 degrees Celsius. And Z is always constant, Z is taken as 10 degrees Celsius. It is assumed always as 10 degrees Celsius. Now you can easily substitute all the values and find the F naught. Okay. In the second one, F naught is the equivalent exposure time. Okay, that is what asked in the first case. But in the second case, if the equivalent exposure time itself 30 minutes, like F naught is given in the question. Okay. At constant temperature 110 degrees Celsius. Temperature is also given. How long will it take to complete the sterilization? That means here you are asked to find the time taken. That is nothing but temperature, holding time. Okay. So here the delta T and T are given. They are asking the F naught value. Here F naught and T are given. They are asking you the delta T. That is the difference. So first substitute the given values in the formula. Uh, so substitute the value in the formula. So we know the formula is F naught is equal to holding time delta T. Holding time is nothing but residence of the particular waste material at the particular temperature in the autoclave. Okay. Summation of 10 power T minus 121.1 is the standard temperature. So the working temperature is getting subtracted from 121.1 in all the cases. And Z. Z is also standard. You can assume it as 10 degree rise. Okay. So 10 degrees Celsius. So now this is the Z value. So now substitute the data. Delta T is given as 20 minutes. Substitute it here. So 20 into 10 power capital T temperature is 125 minus the standard temperature is 121.1 whole divided by 10. Okay, this is the Z value. So you will obtain the F naught value as 49.1 minute. This is the equivalent exposure time. So they are asking what does the result signify? What is the meaning of this? They are asking. So 20 minutes of sterilization at 125 degrees Celsius is lethally equivalent to 49.1 minutes of sterilization at 121.1 degrees Celsius as F naught value. Okay, they are comparing the values. If you are increasing the temperature to 125 degrees Celsius and you are holding it for only 20 minutes, the standard sterilization temperature is 121.1 degrees Celsius. So if you are doing the same thing, it will take about 49.1 minutes for completely sterilization. Okay, that is what the result implies. Now coming to the part B, here the F naught itself is given, equivalent exposure time itself given as 30 minutes. Substitute the F naught value, which is 30 equal to delta T is unknown. So 10 power temperature is 110 minus 121.1 divided by 10, which is nothing but 386 minutes. So this is the time required to complete the sterilization. So what this implies means if you are holding the temperature 110 as constant for 386 minutes at 110 degrees Celsius is equivalent to 30 minutes of sterilization in 121.1 degrees Celsius. Okay, this is the significance of this result. Any doubt in this problem? Shall we move on? Okay. So coming to the next problem, the question is typical BMW has a so this is BMW is a biomedical waste here. Okay, so typical BMW has a moisture content of around 30 percentage and roughly 8 percentage of the dry mass of BMW is hydrogen Using the high heating value of BMW 13,902 kilojoule per kg, estimate the latent heat of vaporized water and the lower heating value. These are the two unknown data. One is to find the latent heat of vaporization. Second one is to find the LHV, which is nothing but lower heating value. For that, you have to take the assumption 1 kg basis. So we are assuming that 1 kg of waste is there, and in that 130% is moisture H2O. So which is nothing but 0.3 kg. In 1 kg, 30% means 0.3 kg of moisture is there, and 8% of the dry mass is hydrogen. Okay, so total dry mass is 0.7 kg. If 0.3 is the weight of moisture, remaining is the weight of the dry weight. Okay, so dry weight of the waste, which is nothing but 0.7 kg. So in this 0.7 kg of dry mass, 8% is the hydrogen, okay, H2. So 0.7 into 0.008 is 0.056 kg. This is the total amount of hydrogen present in the dry mass of the biomedical waste. Now, uh, we are going to calculate the latent heat of vaporization, which is QL. So the formula is QL is equal to 2440 into W plus 9H. This is the standard formula here. So you substitute the weight, total uh, weight of the hydrogen here in the H, and then here in the W, this is the water content, okay, kg of moisture per kg of waste, which is nothing but 0.3, and H is the kg of hydrogen per kg of waste, which is nothing but 0.056. Substitute the value 0.3 and 0.056. You will obtain the QL, latent heat of vaporization of water, which is 1961.76 kilojoule. Okay, so the first part is now over. So next, the second part is to find the LHV value, which is the lower heating value. For that only, we already have the higher heating value, which is 13,902 kilojoule per kg. This is the maximum amount of heat that can be produced. In this one, some part of heat is lost in the form of latent heat of vaporization of the water. So subtract this value from the HHV to obtain the lower heating value, which is 11,940.3 kilojoule per kg. You can stop with this, or no specific unit is asked here. If it is required, then you can take this conversion, like 1 BTU per pound is 2.326 kilojoule per kg. So this much kg is converted to BTU per pound, which is nothing but 5,133.4 BTU per LB. Okay. Any doubt in this question? Any doubt in calculating the latent heat and lower heating value? If no doubt is there, then we'll move on to the last problem. So, so the last question is the composition of flue gas on dry basis from an incinerator of a biomedical management facility is as follows. So the composition of the gas is 12.3% is carbon dioxide, 5.1% is oxygen, and the rest is nitrogen. Okay. From these data, calculate. It has four sections. First one is calculate the weight ratio of hydrogen to carbon. So H by C ratio is asked in terms of weight by weight. Okay. Next, calculate the percentage of carbon and hydrogen in the dry waste. So percentage of carbon, percentage of hydrogen is required. Okay. Next, percentage of excess air. So excess air, how much amount of air is provided in excess is to be calculated. Next question is calculate the moles of the exhaust gas. So here you have to find the moles of the gas, okay, per discharge from the per unit kilogram dry waste burn. Okay, moles of gas per kg of waste. Okay, in this unit you have to find it. We'll see this one by one. First, from the data given, 12.3 percentage is carbon dioxide, 5.1 percentage is oxygen, rest is nitrogen. So assuming 100 mole basis. Okay, here we are assuming in a mole basis, since the final answer is asked in mole per kg. So carbon dioxide is 12.3 moles. Oxygen is 5.1 mole. So our nitrogen is 100 minus 12.3 minus 5.1, which is nothing but 82.6 percentage. Okay. So if nitrogen is 82.6 percentage, then how much oxygen is supplied in the form of air? Okay. We know that air is composed of nitrogen and oxygen. So nitrogen is 79 percentage in air and oxygen is 21 percentage in air. So if nitrogen is 82.6, which corresponds to 79 percentage, what is the 21 percentage, which is the amount of oxygen supply, which is nothing but 22 moles. Okay. So total amount of oxygen supplied in the air is 22 moles that we have found with the help of the nitrogen content. Now oxygen consumed, this is the data given in question. Okay, sorry, oxygen left out in the flue gas. Okay, oxygen left out in the flue gas is 5.1 moles. Now what is the O2 consumed during the combustion? So 5.1 is released out. Okay, and 22 is given. This is given, this is released. So what is consumed during the combustion means this is 16.9 moles. Okay, 16.9 moles of oxygen is consumed. Okay, now we have written the stoichiometric equation. This will help us to calculate the weight of carbon and hydrogen relative. So now from the flue gas composition, it is evident that waste does not contain sulfur, chlorine and nitrogen. So thus 12.3 moles of oxygen is consumed by the carbon during the combustion. So how we are determining that carbon is consuming only 12.3 moles means for every 1 mole of carbon, 1 mole of oxygen is required. If 12.3 moles is corresponding to the carbon dioxide, okay, similarly, 1.1 mole of carbon dioxide is produced from 1 mole of oxygen. Then 12.3 moles of carbon dioxide is released in the flue gas. So amount of oxygen consumed is 12.3 moles, same as the carbon dioxide. Okay. So now the remaining amount is consumed for the consumed by the hydrogen. Okay. So totally we know that 22 moles are there and 12.3 is consumed by the carbon dioxide production and 5.1 is released as the excess air in the flue gas, and then what is the remaining amount is 4.6 mole, which is the amount consumed by the hydrogen for the formation of water. Okay, now we know 4.6 moles of oxygen is consumed by the H2 to produce the water. Okay, therefore H2 present in the waste. Again, we are now calculating the amount of hydrogen present in the waste indirectly with the help of oxygen. So 1 mole of oxygen means is reacting with 2 moles of hydrogen. If 4.6 moles of oxygen is consumed by the H2, how many H2 should be there? 4.6 into 2. So it is 9.2 moles. So amount of hydrogen is 9.2 moles. So now we know the hydrogen moles, which is 9.2 moles, and we know the carbon moles, which is 12.3 moles. Just multiply. We again use the simple formula, moles is equal to weight by molecular weight. So to find the weight of the hydrogen, weight of the carbon, multiply the moles with the molecular weight. So H2, the molecular weight is 1 into 2, 2, and carbon it is 12. So 12 into 12.3 is 147.6 gram and 9.2 into 2 is 18.4 gram. So now we know the weight of the hydrogen and weight of the carbon. So the first part is to calculate the weight ratio of hydrogen to carbon. So 18.4 divided by 147.6 is 0.125. So the first part is over. This is the H to C ratio in the waste. Okay. Next, the second part is to find the percentage of carbon and percentage of hydrogen. For that, we should know the total weight of the waste, which is obtained by adding these two. 18.4 plus 147.6 is 166 gram. So, in this 166 gram, 147.6 is the weight of carbon. So, 147.6 divided by 166 into 100 will give you 88.92 percentage. So, this much percentage carbon is there in the waste. And for hydrogen, 18.4 divided by 166 into 100 will give you the 11.08 percentage of hydrogen in the waste. So now the second part is also over. Next is to find the excess air used. For that, you have to divide the O2, like the air O2 released in the flue gas. Okay, this is the O2 released in the flue gas. Okay, and then O2 consumed. Total O2 is 22 moles. We found it. Okay. Total O2 is 22 moles. In this, only 5.5 is left out, rest are consumed. So 22 minus 5.1 is O2 consumed, and O2 in the flue gas is 5.1. So divide 5.1 divided by 22 minus 5.1. So the excess air supplied is 30.18 percentage. Okay. Now the part 3 is also over. Finally, you need to calculate the moles of the exhaust gas. Okay, moles of the exhaust gas discharged from the unit per kilogram dry waste burn. Further, you need to calculate the total moles. Now we should know what are all the exhaust gas: carbon dioxide and oxygen. So carbon dioxide uh, and oxygen, these are all in the flue gas. Okay, so now in the exhaust gas, totally the water is also produced. Carbon dioxide, oxygen, and nitrogen together, the total moles of the flue gas is assumed to be 100. So substitute that 100 here. Along with this, water is also formed. So for that, how many water molecules are formed? Two water molecules are formed. We know that for 1 mole of O2, 2 moles of water is formed. We know that for the hydrogen production, 4.6 moles of oxygen is consumed. So 4.6 into 2 is 9.2 moles is the moles of water. Okay. So add 100 moles of gas plus 9.2 moles of water. This is the total moles in the exhaust gas divided by the weight of the waste. So weight of the waste is 166 gram. So you will obtain 0.658 moles per gram, which is nothing but in terms of kg they have asked. So you convert it. So 658 moles. Okay, it will be like 658 into 10 power minus 3 moles per gram. If this 10 power minus 3 comes down, it will become kg, 10 power 3. Okay, so 658 moles per kg dry biomedical waste. This is how the fourth part is calculated. Okay, this is the step-by-step breakdown of the problem. Do you have any doubt in this problem?
Ma'am, explain once again the initial assumption part where you are
Hmm.
taken moles part.
Yes,
That
100
part is
moles.
clear. Yeah, yeah. That 100 moles and their percentage in oxygen of this part available, this nitrogen part of this.
Okay,
Yeah.
okay.
Yeah,
You have a doubt in this one, in this part.
yeah. That part only. Yes.
Oh, okay. So we know that the flue gas composition is only three compound. One is carbon dioxide, another one is oxygen, another one is nitrogen. So we are assuming that flue gas in mole basis. Okay, since this is given in dry basis, this is only the composition of dry gas. No water is here. Okay, so we are assuming this as the 100 percentage. So if this is 100 percentage, we are considering the mole basis here for solving. We can take weight basis, volume basis, mole basis. Here in the question, the mole based answer is required. So we are assuming the mole basis. So take total flue gas as 100 mole. If 12.3 percentage of CO2, then 12.3 moles of CO2 are there. Okay. 5.1 percentage means then 5.1 moles are there. So 100 minus 12.3 minus 5.1. Only three components are there now in the dry gas. Okay. So you subtract these two from 100 means 82.6 percentage. That is 82.6 mole belongs to the nitrogen. Okay. Here in this
Ma'am, either my question either nitrogen will remains like that only, it will be yeah, NO2 form or dioxide form.
no. If it is in
Yeah.
nitrogen dioxide,
Oh,
nitrous oxide, then in the question itself they will mention that no. Rest is the nitrogen only
okay.
they have given. Okay. Nitrogen means
Okay.
N2.
Nitrogen means N2 form.
Yes. Okay. If
Okay.
it is any other
Okay.
gaseous form, then its
Yeah.
composition percentage will also given in the question. It is not
Yeah.
now
It is
given.
okay. I got confused here only. Okay. No problem. Yeah. Please explain.
Yeah.
Yeah.
Okay. Okay. Any other doubts?
No, ma'am. Rest is clear. I thought it will be in gaseous form because during incineration only gaseous fluid gas will come. No, either will be
Yes, you can adjust
dioxide
the
or
equivalence. You can
nitrous
adjust
oxide.
the equivalence
Yeah.
ratio such that only the carbon compounds and hydrogen compounds are consuming the oxygen. Okay.
Yeah. Okay, ma'am. Right. Right.
Okay. So now, if no doubts, thank you. I think this is your last week of live session.
Thank you, ma'am. Please take one revision class also, if possible.
I have already taken one extra class on October 2nd.
Okay.
Yeah, I have summarized. You can find it in
Uh,
YouTube channel.
okay.
I have summarized the 10-week lectures. Okay.
Okay. That part I have missed. Okay, no problem. I'll take that one. Thank you.
Okay. Thank you. Thank you for joining all the classes. All the recorded videos are there on the YouTube channel, and the course content is available on the Drive link. You can refer the notes, all the rest for your exam. Thank you.
Yeah, thank you, ma'am. Thanks. Yeah, it's a pleasure.